Number 5. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. Does the ball reach a height of 25 feet? What about 10 feet? Explain your reasoning. So the first thing I'm going to do here is I'm going to try to construct a function. And keep in mind we have our function that h of t equals negative 16 t squared plus v naught t plus s naught. In this function, the negative 16 is representing gravity, v naught is your initial vertical velocity, and s naught is your initial distance off the ground. So h of t is just the height of my object with respect to time. Negative 16 t squared I'm not going to touch, plus the v naught is my initial vertical velocity, which they told me it was thrown at 30 feet per second. So 30 t plus s naught is my initial height above the ground, which is 4. Now, the first question we're being asked, we have this function, it's going to model the ball. So roughly, and we'll go look at this more specifically, but roughly, it's starting up here at 4 feet. I'm going to throw it, it's going to go up, and then it's going to come back down, and it's going to hit the ground. Now, the first thing they're asking is, okay, well, does the ball reach a height of 25 feet? Meaning, if I look at that as an equation, and I want to know if it makes it to 25 feet, I would come over here to my h of t, and I would say 25 equals negative 16 t squared plus 30t plus 4. Is this going to happen? And I can kind of like put it in a question mark. The long way of doing this, which I'm actually not going to do, is you would subtract 25, make it equal 0, and then solve it. If your solutions are imaginary, then no, it doesn't make it to 25 feet. If your solutions are real, then yes, it does make it to 25 feet. But I'm actually going to do this a little bit differently. So before I switch my screen and go to my calculator, keep in mind the left side of your equation says 25, and the right side of your equation has your function. So now, grab your graphing calculator, or go to Desmos, which is what I'm going to do. And in the first box, I'm going to type my function, negative 16x squared. Keep in mind you have to use an x. This calculator won't recognize t. Plus 30t, or 30x, plus 4. So if we kind of look at this over here, this is what's happening with our function. So we're throwing it, it starts over here at 4 feet. I could kind of find that, that's my y-intercept. It's going to go up, and honestly, you could probably just go find the vertex, because my vertex is up at 18. So we've already answered our question, does it reach 25 feet? No. The highest it ever gets is 18.063 feet, so roughly 18 feet. And it does that if you look at your vertex at 0.938. So our vertex is 0.938, comma 18.063. So I'm going to come back. And does it ever reach a height of 25 feet? I'm going to write no. The max height is about, and I'm going to specifically say about because this is rounded, 18 feet. So if I look at my graph here, I could say that this is at like 0.938, comma 18.063, and then I could do like a little arrow so that my explanation also comes with a picture so that my teacher knows what I'm talking about. Now, the second question is, does it reach a height of 10 feet? Okay, let's go back to our graph. Well, if the vertex is at 18, then yeah, it definitely hits 10 feet. That's right here. So if I want to be very specific, I'm going to come back and I'm going to write y equals 10, because I want to know when it's at 10 feet. So just y equals 10, and notice this blue line. So now I've got this point here, which I'm going to record on my paper, 0.228, comma 10. And this point here, 1.647 comma 10. So it actually hits 10 feet twice. It does it on the way up, it does it on the way back. So part 2 would be 10 equals negative 16 t squared plus 30t plus 4. And that was our question. And it's yes. It hits 10 feet at, and then our first one was 0.228 seconds. And our second one was 1.647 seconds. And then on my graph, I could come up here and I could draw like a line and put 10, that's my 10 seconds, and then right there, and right there. And again, it's always kind of nice to have a picture to go with your answer, and that could be your explanation.